if you were watching yesterday's video, I walked into a really classic power-up issue. This should be blank right now. If you don't recall that, yesterday on my stop logic, I said, also probably power-up. Actually, that'll cover power-up. That'll cover power-up. Well, it would if when you powered it down, you didn't lose connection. So let's look at this, because I actually probably, we did a live stream on the PowerFlex yesterday. This is probably a bigger issue with devices like that when we're looking at the drive fault. And here is that rung, and what I said is when the smart safety drops out, that would unlatch it. Well, it is dropped out right now. So let's figure out why we have a 1 in it right now. Mark right click, cross-reference, double click on that destructive column, and we got 1Y. So we'll double click on that Y. And it says right now that our smart safety output is on. Now the issue with trusting this is this, and this will always stress it. And even in the training class, everybody ignores it until the end. It's funny, they'll come back and they're stressing it. People usually told me this is smart safety I2. No, this is smart safety colon. And that colon's the most important part in that sentence, because that colon tells us we need to look down to the bottom left. And now if we go look at our smart safety, then it's going to have a little microscopic little yellow triangle by it. And so since we're not communicating with it, it can't update this tag. So we need to know whether that is connected or not. And we have a lot of videos on using the GSV, but I already have it. Actually, it is the rung beneath it. All the logic that I said yesterday that I need to clean up, it's in this logic. It is, see, here's all of the stations. And if we go down here, then there is the smart cell Ethernet switch connecting faulted. And we mouse over it right now, it has a 1. That should have been in there. So now, whoops, scrolled way too far. Everybody's been in my class is like, he scrolled. Yeah, there you go. I got excited and scrolled and blew right past it. So right here, we need to add a branch level. We need to bring down and go look for a 1. And, whoops, actually I have the whole thing in my clipboard. We just need to double click and change that to a go look for a 1. And that would have shut that off. And we should see that light go out. There it goes. So we'll load ourselves another frame in there. Hit our safety reset. Start it. And now I gotta wait 13 minutes, but might as well finish the frame while we wait, and then we'll see what that display says. But it is interesting, I get to read a lot of people's safety checkoff list, which actually I'm doing the checkoff list right now because we have class next week. But, I see things about ergonomics. I see things about the paint color for the guards. I almost never see what happens to a machine when the power fails. And while, yeah, this was just a basic display, what happens to your machine when the power fails, or mainly when the power comes back on? And it is surprising the people that shrug on that, and they're like, well, no. But it's surprising how terrifying a lot of machines are when they power up. I was getting impatient. I remembered I had this % complete code, and I noticed the % complete is at 0 right now. And I don't fully understand why, because this number is definitely not equal to 0, so it should be doing the compute. We got a number there. We got a number there. We got a number there. Why is that sitting at 0? Now this should probably be a real number. Have I ran into one of those real number traps? Well, let's find out. We'll just copy that. I'm going to stick real on the end of it. And then we'll make sure we create that as a real data type, and if I'm really fast, I might get this done before this is complete. Looks like I got about 80 seconds. Oh, now that is 100% video worthy. Here's a good example. In fact, I may have to break this out. I think I will. I think I'll have to break this out right now because, yeah. And I see this in a lot of programs. Because this is a double integer and this is a double integer, and that one doesn't fully make sense. Oh, that does. Yeah, we actually go through this on Tuesday of our training. But yeah, since that is a double integer and that is a double integer, it doesn't round. It actually goes down by 1, which means 0 times 100 is always 0. We make it a real number, and yeah. Okay, so now it is saying swirl needs frame, but I'm going to go power off the machine.
You should say frames need swirl, not swirl need frame.
And that's why I went to English in summer school. Okay, so I am not going to break the light curtain. I'm just going to reach down, turn the disconnect off, and it clears out like it should now. Now, sometimes you put something on your machine and later on you're like, could I have made an uglier setup? So I have this thing right here. Now the whole point of this is really to show on this safety module right here, this is easily bypassable. And that's why we have items like this RFID sensor that there's not an easy way to fake out. But as many of the students that come here on this have already stated, that's the clunkiest looking switch they've ever seen. And it's not truly safety rated because really you would never do probably a switch like that to this. But in this case here, I've got a Turk safety rated switch. But this is going to be an inductive proc switch. There we go. That looks slightly better. And mainly, and it's not that it's unsafe, you have to assess your risk because somebody could set a piece of metal on this one. And we reach over, whoops, gotta hit my safety reset. Then we can reach over and we can run the machine without closing the lid. Place is starting to look like a training center again. Oh, actually, there's the last 3 of the original trainers when we built this. Kind of sad, but I really like the upgrades.